Six.
Six.
We're not the fifth.
I'm
Because
sorry.
Oh wait, yeah,
that's a
right.
Broda.
There's
Oh,
not
hey.
some loans there tonight, so,
I'm the only,
yeah, we're not gonna be able to
one in
hear
the low
you
brass.
guys. I'm sorry.
I have to play trumpet.
You mean the flugelhorn?
No, the trumpet. Wow.
Dude, the flugelhorn is fire.
Flugelhorn? Have you ever even seen a flugelhorn?
Yeah.
Yeah, a kid asked me if I was going to the game tonight, and I almost like laughed in their face. I was like, it's not that I don't like basketball. I actually kind of enjoy sports. It's just right now, my only thoughts are getting through the play and keeping my children alive and my house somewhat okay, and like teaching minimum. You know, like we're just barely floating here. You know, like if you think I'm adding a thing where I go somewhere, no, that's crazy
If you
talk.
didn't have clocks, you wouldn't have to have time management. See?
Sure.
Yeah. See? We didn't
Well,
know the time.
I'm glad we've been recording this conversation for the last minute. You can go back and think about it in the future, if there is a future.
There isn't, because there's no clocks.
3,
I'm gonna become the
6,
president. I'm gonna become the president just to get rid of clocks.
3, 6.
Well, if there's no time, there
I
would
think
be
so.
an 8. It would just be
All right. Here we go, guys.
Yes,
We are going to talk about confidence intervals today. We're actually more than halfway through the AP curriculum. Even though we have to get through 10 chapters to cover it all, the last 2 chapters are I only cover 2 sections each in those chapters because those are the ones that pertain to the test. So really, and chapters 6, 7, and 8 are a little shorter than 5. But the math's a lot harder in 7 and 8. And also in 7, I'm going to have you guys do a big stats project where you are going to do like a thing where you go around and collect data around whatever you're interested in and test a hypothesis. And then after the AP test, when we have extra time, I'm going to have you do a 2-sample hypothesis test where you compare 2 populations. So you can be like, I think students have faster reaction times than teachers, and devise like a test for that. Or I think that sophomores are better at shooting baskets, like free throws, than freshmen, you know, like, or whatever, and you compare 2 populations and test them both. So that'll be fun. It actually is really fun. I know a project never sounds fun, but it's actually pretty interesting, as long as you get to make up your own stuff. Okay, so a confidence interval is a range of values that the mean is predicted to fall within. It looks like this. Kind of like a stretched out TIE fighter from Star Wars. Do you know what I'm talking about? Those one ships that are like, "Ah," when they go. This number in the center is the point estimate. In this case, so it's the center or the mean that you're predicting. It goes right here. And then you have numbers on either side that it could possibly be between. The level of confidence is how confident you are that the true mean is within those boundaries. Okay. Let's have a quick discussion about this and see if we can get it. So imagine I had to say, what is our score going to be at the game tonight? Okay, if I said, well, this is my guess for our average, but I think that our score will be between here and here. Okay, so I've got like a range, right? Or I'm like, it'll be between here and here. And I say, I'm about 75% confident that our score will be in here. If I was 95% confident, do you think that I would have to make this like a bigger range or like a smaller range if I was 95% confident compared to 75?
Smaller.
Okay. Bigger?
But if you're more confident, smaller.
Yeah, you would think, oh, I'm more confident, so I'm going to be more precise. But actually, it's more like you have more wiggle room. So like, for example, what's the temperature going to be tomorrow? I think the temperature tomorrow is going to be between 52 and 54 degrees. And I'm like 20% confident about that. I'm like 99% confident that the temperature tomorrow will be somewhere between -50 and 150 outside tomorrow. And I bet I'm right. See what I mean? So if I really widen my range, I can be really confident. But if I narrow it down, I'm less confident. And not necessarily more accurate, but less confident. Okay, so critical values are z-scores. So we're going to need those z-tables again, so go ahead and get it out. A16, A17. Which again, I hope we're all aware that when I say A16, A17, I literally mean literal pages of the book. These are not called A16 and A17 anywhere else, except for in this curriculum where they happen to be on pages A16 and A17. So don't go to college and be like, oh yeah, those A16 tables, nobody's gonna know what you're talking about. That's just this book. Really messed me up because they redid this book and we got the newer version like a few years ago. And they used to be on A12. You don't know how many years I've been like, take out your A12 tables. They're like, what table? And I'm like, gah! Changing those numbers. All right. So we're trying to find the critical value for a level of confidence of 95%. And so we want that 95% to be right in the middle. So everybody draw a quick bell curve. And draw a line on either side of it and write 95% in the middle. So if we had 95% of the data in the middle, what would the z-scores be on either side? What percent would be on the tails over here? 2.5%. So how are we going to look this up in the table? .025, not 00. So look up in the middle of the table, because we're looking up a probability or an area. So in the middle of the table, you're looking up .025. What'd you get?
-1.96.
-1.96 and +1.96 if you looked up 97.5. But it's also symmetric, so you can just look up 1. Okay, the margin of error formula is margin of error. Yeah, okay. So the error is z sub c times sigma divided by the square root of n. Which you'll recognize that sigma divided by the square root of n as the thing that we used in the central limit theorem. And z sub c is that critical value. So this is critical value.